start off by factoring completely. Non-permissible values. X can't equal -5 and x can't equal 5. They don't cancel out. So we have vertical asymptotes at -5 and 5. Next, horizontal asymptote or oblique asymptote. So you have to look at the degrees. We have 3 situations, right? Degree bigger on top, degree the same, or degree bigger on the bottom. This is the situation where the degrees are the same on the top and the bottom. There's an x squared on top, there's an x squared on the bottom. When the degrees are the same, you will always have a horizontal asymptote, and it will be at the coefficients of those biggest powers. So we have a -2x squared divided by a 1x squared, -2x squared divided by x squared will just become -2. That is our horizontal asymptote. Y-intercept, oops. Plug in 0 for x and you get 0 for y. That's also an x-intercept. When you plug in 0 for y, you get 0 for x. I also want you to notice that that's the only place that would make your numerator equal 0. So our only x-intercept is also 0, 0. Now, when we go to graph this, draw what we have so far. We have vertical asymptote at 5, vertical asymptote at -5, and we have horizontal asymptote at y equals -2. And the only point we have so far is 0, 0. This is a great example of we don't have enough to even draw anything right now. You have some problems here. We don't, from that 0, 0, you don't know if it goes up towards the asymptote or down. Because it could possibly go through a horizontal asymptote in the middle. Or maybe it goes up on one side, down on the other. So we're a little bit unsure there. So we're going to have to find some nice points. I'm going to list them here. We're going to need something in this section, so we're going to need -6. We're going to need something in the far section, so I'm going to need +6. And in the middle section, since I don't know if it goes up or down, I'm going to check -4 and +4. Lots of nice points I have to plug in, right? There's no limit. You can keep plugging in points and keep finding more things if it's going to help you out. Sometimes, if you feel like a point is, like, you will make a mental math mistake sometimes when you plug in points. And if you're like, something seems wrong with this point, you might plug in some more points just to double check. And then that might give you a hint, I should recheck this one. Okay, now, plugging in -6. I'm going to go, you could either plug that -6 into your original equation or into the factored one. -6 squared is 36 times a -2. You would get -72. -6 plus 1, -1. -6 minus 5, -11. -6 plus 5 is -1. That simplifies to -72 over 11. Now, if you're trying to figure out what that is, you know that 66 divided by 11 is 6, 77 divided by 11 is 7. This is going to be somewhere in between -6 and -7. So I'm going to go 1, 2, 3, 4, 7. I can label this point in -6, -72 over 11. And by having that point, I have enough in this section to draw towards my asymptotes. Now, we can plug in 6 as well. Also, you can look at the original equation. With the original equation having x squared, can you see that if I did negative 6 squared, or if I did 6 squared, it's going to come out to the same thing? And so for that reason, I know that this one is also going to be negative 72 over 11, and I can graph that point at 6 comma negative 72 over 11, and draw that section. Plugging in negative 4. If I plug in negative 4, negative 4 squared is 16 times negative 2 will be negative 32 on the top. Negative 4 plus 5 is 1. Negative 4 minus 5 is negative 9. I will get negative 32 over negative 9, which of course is 32 over 9. 32 over 9 is somewhere between 3 and 4. So if I go to estimate it, negative 4 between 3 and 4. And I know this section has to go up. Okay, same reason that negative 6 and 6 were the same is going to be why negative 4 and 4 are the same. This will also be 32 over 9. And the other thing you could have noticed, okay, it has to go up as well. The other thing you might have noticed is that the x-intercept, you see that it has a multiplicity of 2, because we have an x squared. So it bounces off 0, 0, which shows up in our graph as well.
Hi, could I please have Chase to the office at the bell?
Sounds good.
Thank you.